Hello. Hi. This is another part of designing this module. It's a completely open source module designed to be completely makeable by yourself without any soldering. Yeah, so I'm just going to continue today. A problem I have found out recently is they've stopped making these jacks. So today I'll probably swap these jacks over and continue working on the SD card. I had a thought. Just one moment. I realised that this isn't going to work as it is. It's probably going to have to go right to the board edge, because well, not right to the board edge, but because this little board is not going to fit easily through, and I want to get power from this part as well. So what I might actually do is I'm going to have one socket for the power and one for the data. So on this one, data is missing. It's best to use the same parts twice. And on this board, power's not there. It's going to need another socket here. Don't know, let's see. It would mean there would need to be a connector there, and on this board, connector on that side. Ah, that's the problem. That would get in the way of that. Huh. this is changing anyway because I apparently can't get this jack anymore, even though I just reserved 150 of them. But oh no, I've lost it. If I go to the most available jack connectors and go to the second page, I'm just wondering if they're stopping production, stopping stocking, all these things. I don't know. It's not that one, because that one is too deep. Yeah, it's 12mm deep. We want yeah, that's it. It's a bit like the Funky-Con, but unthreaded. So let me just put it as a note here for myself. That is 10.1mm deep. A bit more actually. That's a bit annoying. It's probably 10.2. What grid is this on? Yeah, that's 10.2. That would mean now there's a little bit more space. Not that much. Maybe it needs to be a... I mean, to be honest, they both could be just simpler headers. This is 1, 2, 3, 4, 5, 6. It's going to have to be 8 pins. I'd rather they were the same. I don't want to have lots of different types of connectors. But oh. This is too long, right? Yeah. So we want an 8. So we want an 8-pin socket. So this is it. You're constantly going back and forth. That's not right. This never works. This. Okay, nothing in stock. Literally 0 in stock. Two millimeter, 1.27. That's a socket. Oh yeah, we need a right hand socket. Man. Thinking about it, it might be quite good if it went downwards. So what if they were... Oh, it's quite expensive, that. I know it's in its 10p. What if it was a simple vertical socket? So on the board it was this. And then the header was a right angle. What they called female headers, pin headers, 1.27 single row in stock. Yeah, so if you do that, you never get anything. Oh no, that's because I did insulation height. We want 8-way. But ideally right angle. You go. So if we do those, and I'm just going to have to I'll let you look at the schematic. Just one moment. What I've got to do is I've got to get those footprints. So I've got to copy C41, C74 once, and this one. And you can't see what I'm doing now, but I am I'm copying the files across, the footprints that are directly copied from the JLC PCB using this cool tool called it's JLC 2PCB. So these are called J11, J19, J11 and J28. These two they're now called, I'll just have to look at it like this. I think it's there's that one. That's the right angle header. Yeah, no, we want the right angle. We want the single row for those ones. And then for J19 and J29, we want to use this one. I'll update it. See, these have now become these funny things. Ah, that's a problem. Now that means that's all the way up here. Well, no, it'd be more like there. This will be somewhere here. I don't know why they're all connected to each other. I think it's because these are nets. Oh, it's the SD card. No, that's still not good though, because so if we look at the footprint, this one. See, that's the idea. But the PCB is going to be there, so it was going to be all the way up here. I actually think it's better if it's the other way around. So these should go on the don't know if I changed that by mistake. Seems like it's missing ground as well. Now they've swapped, so wait, which one's which? This one's going to be here. It's going to be sticking out sideways like this. This one's a header, which is on the lower board. Yeah, that works much better. And the other one is here. It sits like that. And it will be over here somewhere. So if you look in the 3D, oh no, I need to get the 3D models in. What? And then on these are straight vertical. I think it's this one, yeah. So it's hard to explain, but the idea is that this board and this board will have a socket on it. And it will slide in sideways. But the top panel now is not going to be holding the SD card. This is going to need some kind of mount. Hi, EAX. Yeah, I'm planning on releasing it at Super Booth, maybe. Bit tight though, because it's the it's in 3 weeks. 1, 2. But I'm hoping to get it assembled next week. Then it might just arrive just before it starts. It probably means it won't have any software on it. Yeah. But I think once I get this main board done, then all that'll be left is this layout work for the connectors, which is somewhat faster and less complicated. I just need to solve this physical thing. I'll reply in the chat. Hopefully Super Booth in the next thing I got to do so I've got this so it goes in, plugs in sideways. Maybe it shouldn't be on the board edge. Now I've changed this configuration though, I could probably be rid of this. Maybe I don't want to be rid of this. I just can't, I shouldn't have it on the edge because I want this tab up here to get trapped in the front panel. So it should definitely be in a bit. Problem is I've got this whole switching slate and this inductor that's way too large. So that's another thing I should do. Try and find another inductor. Inductors. Need power inductors. 3.3 microhenries. And it needs to have saturation current. Oh, let's just do that. Most commonly available. Hey, this most popular one seems pretty good. I based it off the Adafruit Metro 2350. And they specified a 5-ish amp inductor 20 milliohm. Okay, so that's not enough. 4 might be alright. Right, this one's 8 and this one's 6 by 6 millimeters. Currently this is massive, this is like 10. Yeah, way overkill. This one looks good. Not shielded. But let's give it a go. And I've got to do my conversion program. Footprint. So now I'm just copying this new inductor, which is a 5.4 by 5.2 inductor. Might be easier doing it here. What is it? It'll be an L. JKL. Oh no, it's not that one. Green screen. .4 by 5.2. Bing! Look how much smaller that is. Now, I've messed all this up now, so yeah. This is all my I need to rethink that. Let's just put it down there for a minute. What's this capacitor for? I'll need to redo the whole switching supply there, but in the meantime, I'll put this in, and what I'm thinking is no, it's fine. I just need to, if this is pushing in the side here, I want to make sure there's a little bit of board to hold it in. So I don't want it to be completely in at the side. I should take a significant step back like that. And I need to determine where pin 1 is. I need to do a drawing to show that line there, you see. That line there, you see, is the extent of the connector, so it will be there. And I had to measure that is a certain distance from the board edge. So that's 7.4 from there. So over on this one, see that's 8.3. So I need it to move 9.9 up. We can do that by doing move exactly minus 0.09. Right. No, that's 8.2. What do I need? 7.9. 7.4. So this is the wrong way around. No, it isn't, because it's upside down. Yeah, that's the point. Yeah, don't worry about that. Yeah, getting sidetracked. It's 8.2, so I need to go up 0.3. Keep forgetting the numbers. It's 0.4, so it's 6, 7, 8.8. Oh. There you go. So there now, these two connectors are aligned at the same point as each other. Away from the board though, that's 7.9. Should just add. So 6.3, so that's 7, 1.6. Move exactly, I think x minus 1.6. There you go, that's 7.9. In theory they should be on the same line. I might just double check though. That's 48.5. Yeah, they're the same width as each other. Thanks. Thanks, EX. Don't know what to call you. Thanks. I'm just doing this really annoying bit, but I've just realised this. So it's quite hard to imagine. There's this header on this side. Oh, you can't see this, wait a minute. There's a header on this side and there's a header on that side, and they're going to be on top of each other the opposite way around. That means one is going to be on the underside. The upper one, which is this one going green, is going to be on the underside of the board. Ah! No, it's not. Ah, and this one's going to be on the back. So actually, this is wrong, because if you imagine here, I should probably draw this out. Like, what I measured here, you see, is they're the two 1.6mm boards. So this is the stack that is under the PCB between the front panel and the connectors, and then this is the gap in between the board. And what I've realised is this one is actually on the back, so this connector is going to be, now we're doing a dangerous thing here, we're assuming that our PCB is going to be exactly 1.6mm, and I can tell you that rarely the tolerance is quite loose on those, especially if you do aluminium PCBs. So our connector I guess we'll have to look at the connector at its source. It's this one. I mean, there's not a lot to it. It's 2.5 thick. So if we get another dimension out, we change it to 2.5. That's how big we really want the PCB. We're on edge cuts. So here we go. Wait, there might be some bits of trace left behind. So this connector is actually going to be under here. There's kind of nothing here. In fact, I might make it lower, make this gap smaller, now that I can. Because what I haven't actually shown yet is that that's a point, I haven't thought about that. I think so I'm going to need a spacer that goes between these PCBs. Originally I was going to use oh yeah, that's what I'm going to do. I'm going to put threaded mounts here, and then you're going to need a spacer. Might even just be a single nut. Yeah. 1 minute. So they should be pretty close now. I need to determine what this gap is going to be. It's going to be practically nothing because it's the gap between the back of this board and the back of this board, so it only needs to be fairly slight. It'd be quite nice to make it quite low profile, so probably use some, what do I use? In the UK we've got this supplier called Toby Electronics. Has a pretty good PCB hardware section. Means I could use spacers like this kind of thing. They're a bit fussy. What's the lowest profile? Is it M3? My hole's M3. Yeah. The lowest M3 spacer you can get is which is the L. So maybe do it 4. What do I want? Maybe I'll do it 5 because 5. I'll do it 4. That's far enough away that the move this a little bit. That's supposedly meant to be 5mm thick. So if you look now, it's like that. So what I've got to do is now I think these are in the right place. It's a shame because we're going to lose all this this nice silk screen, but we want to do a nice radius like that. Oops, I think that's the... Oh, that's right. We want it to come out to probably beyond where the header. Ugh. Why is that off? It's moved it by the centre. You'd be really careful in KiCad not to fall off the grid. See, I hope this is making more sense now. No, didn't realise that was a square. So now if you see I've got this slot cut out. Oh yeah, no, it should be more than the width. See that? But I realised the board is quite long. It doesn't need to be that wide though. Nothing's... Maybe it should only just be the width of the connectors. Keep it nice and compact. That's okay. It's quite hard to show what's... I'm being asked 90% of the time, you don't know what's going on, but that's okay. It is quite hard to see what's going on, even if I was watching myself. Oh no, that's too small. I mean, I'm trying my best to show if there's anything anyone wants to know, do ask. Or if there's anything I should change about this format, if you'd prefer it if I showed things a little bit bigger. So maybe hopefully that's making more sense. I've got this little board and it's got to push in the side here, and it takes the serial pins out from the microcontroller, and on this board it's going to take the power, because I've moved a power supply to over here just for simplicity, and it should eventually come out the side here as a little SD card slot. Because what this is, I should actually have this footprint. I should. I forgot to copy it. Oh, there it is. No, that's not it. I'm sure I have it, so it's probably... maybe it wasn't included. Inductor. It's a... Is it this one? Yeah, it's this SD card. If I do, for sake of, it'd be quite good to get the model in. You won't be able to see what I'm doing here, but I'm extracting from the JLC PCB library. It's called TF. That's not it. Oh, it's this one. Oh, perfect. So here you can see the... Wait, that's the wrong way around. It looked right. Oh, that's interesting. I believe it's the wrong way round. That's why 3D models are so useful. And that's how it should go in. This has got a funny configuration. It's a really compact SD card, and it actually is supposed to be something like this. So the SD comes in on that side. Yeah, what would be really useful is if I could just explain here. Oops. As documentation in the file. So it's like underside documentation, user comments. So that's the underside. That's the main PCB. What did I call it? Micro PCB, because it's got the microcontroller on it. Then this is the gap. And then this is the connector PCB. And this is the connector gap, because the connectors are 10mm deep. And then this is a 2mm front panel. So our board is comments. 12.1 millimeters wide. So this gap here has to be 12.1 millimeters. It's 10. Probably 12.2. So we're losing space. We've really lost the place with this capacitor. Now I realise that this has to be in the middle of that. So how do I centralise that? So you're asking, did I design the thing EAX? Do you design the thing where you insert the SD card in yourself? There's no template. Look, there's a connector. There's a proper SD card connector. It's here. And the idea is that SD cards are standardized by most connectors. Like if you go to SD card, it's it's a proprietary standard, but it's been highly adopted. You probably can't say something's SD card compatible without paying them some money. Without using their logos, but the connector, this connector is a standard SD connector. It has it's designed to take a micro SD card, if you see, and then it just has the pins coming out. I've designed an extra connector because I didn't want to route the SD pins to go all the way down here, through a ribbon cable, through this card, and then back out. And the other problem is there's vertical SD card readers are few and far between. In fact, there's only one in existence by Thunk. No, not by Thunk. That Thunk cell. There's only one known. If you can see it here, it's probably here somewhere. Yeah, by Yamaichi. This is the only vertical SD card socket, and I was trying to avoid it because you can't get it from the assembly process. So I was trying to use an SD card reader that's more common, and these really nice small compact ones mean I can fit it in between the boards. But the only problem is it's side mount, so I'm having to make this adapter PCB so that it can fit in vertically. And the idea here is it's kind of an experiment, to be honest, is to make this small little adapter board that vertically fits in sideways on the side of the board. And it's held in place by being trapped at the top and in the sides. I'm not sure if that's the best. I might see if I can have another connector here, or some kind of screw mount connector, because you can get side screw mount connectors, but I think that near the end. In fact, the prototype doesn't need it just yet, and that might be an enhancement if it's a problem. Yeah, what I've got to do now is just got to try and centralize this. I mean, a cheat to do that would be just to select the footprint, select the line, and go align. But the wrong one goes. Ugh. I guess I could then move it. There we go. See, now that's aligned at the centre. That should push in sideways. What I might do later on, before I submit it, I might take this board into a 3D CAD program and move it around and connect it like it was assembled, just to double check everything aligns. Now we just need to copy, wait, that's 12.2, so that's 1.1 millimeter wider than this board. The depth of the header is 4.6. So the header will be so look, our PCB is going to be sticking out the edge a little bit, which isn't right. So what needs to happen is this needs to move backwards slightly. Move exactly, I'll do it by number. Make it 2 on X. No, that's too much. Positioning tools. Move exactly 1.5. That way our header will be like that. And does that leave a 1. Needs to be 1.6. Oh, that's exactly 1.6. Let's see how that goes. So now I'm going to copy this. Not that. Needs to go over here. But it needs to be at the same position, so it's 6.7 millimeters down. Comments. Come on. Stop snapping. There we go, so that's exactly the same position. Oh, that's also same again, that's also a square. So you can see I've now cut a, hopefully without breaking the, and I'll cut a groove on each side, because these boards go like that. So when they're together, they'll be, this cutout will be on the same side of both. And then just got to work out how to align. I'm going to cheat and use a line. And then I've got to work out how to make the depth the same. The depth is, how do I work that out? 9.4 to the edge. Oh, that's not in the center. Let's work out how to get this the same as this. I could just duplicate that. Put it in the same place. No, put it where it should be. Then drag this. There we go. We want J, do we want to delete J19? That works. Oh, I've broken the edge. Oh, I know why. There we go, so they should line up. I'm wondering on the... if there's a way I could lock it in. No, it wouldn't really work. The thing is when you're putting the SD card in and out, you're not putting it... The good thing about these being right angle headers is they're not going to be being pushed in the direction that they'll fall out. Yeah. That seems to work though. So what I need to do now is sort of clear up the chaos that I've created by putting all this stuff in. We've now approximately got an SD card working. For the panelization, I'll make it, it needs to be something like that. And I'll probably give it a ground. Oh no, I haven't aligned these here, these should be centered. There you go. Now they're centered with pin 1. They're centered with pin 1 to the top side. And if that was flipped around and pushed in there on oh, the connector board on the right is the way round we'll be viewing it. So if that was pulled round like that, number 1 is on the bottom, which is great, which it is. But because that one is flipped underneath, pin 1 should also be on the bottom, but it's not. So what does that mean? That means I just need to reverse on the, oh, that was the jack board. That's not jack board, that's the micro board. And then this is on the jack board. And this is on the SD extension board. So we want to flip on this board. So that means, so I should probably route this. But it actually already seems like this should be the other way around. Huh. There you go. the routing's going to be tricky because it's... Well, no, it doesn't have to be on the top, does it? Oh, no, it does. Oh, and that doesn't go through. Oh, no. Can't use the smallest. Because it's a 1.27 pitch thing, I can't get through. Oh, that's power, so that just goes straight through. So it's ground. That's annoying because I wanted it to be quite straight because it's quite a high speed signal. You can, what you can do actually, it is possible now to have, I read that you can now, oh, I know what I can do. It can just have its connections. Because they're not being used. No, not on the jack board. But on this board, so 8 is 8. Oh. 8 is 8. 7 is 7. 66 and so on. Oh, what have I done? There we go, so now it goes through. And I probably want to put in a ground layer in all of it. It's called SD ground. Why is there two SD grounds? Oh yeah, it's got the shield. It's a shield pin. I need to double check if those are all right. Go to the... Here it is. It's got a pin detect. Okay, pin 1. So you do actually have to double check with SD connectors. So pin 1 is data 2. Pin 2 is CD DAT. Pin 3 is command. Pin 4 is VDD. Pin 9. They call it... It's called 9 on the CAD, but in our thing they call it... It's switch. It's switch detect. But I'm using it for shield. Oh, what's the circuit? Open switch detect between thingy and P4. So it can that would cause a short circuit. So we'll just disconnect it. Pin 5, clock, 6 VSS, pin 7, DAT 0, pin 8, DAT 1. So it is standardized to a degree, but you have to watch out for traps. So now I guess I'll route be on the inner layer. We're routing out massive fires. We use the smallest possible fire and trace that I want, that I'm allowing myself. We pull that one back, this one forward, this one back, this one forward, this one back. And then we put it on this inner layer. Maybe what I'll do it's actually really helpful to look at the way this pin is configured. In fact, before I do this I need to double check. I'm on the micro board. Pin 1 of this board is going to be with facing that way. No, it's going to be that way with pin 1 downwards, but that's going to be flipped around, but pin 1 is still going to be downwards. So what does that mean? That means pin 1 is down here. So 8 is DAT 1. which is the same as 1 on this, which is that one. Yeah, that looks right. So what I'm gonna do though is going to reconfigure, move around these pins here, because what we want is that 2 to be starting at. No, I can't do that because this is a fixed peripheral. Yeah, I can't do that, it's a fixed peripheral. So I just had to route it. Bring them back. So there's the clock. There's command. That's 0. That 1. This needs to go above. That. Then where's this go? Command is that. Push this all. Push this all back. Probably try and get this. Delete all these wires. Now ideally I want to make this as compact this way as possible. You can put it into different routing mode. Route. Just highlight collisions. I'm in a bit of a coarse. Put it onto a really fine pitch. Shove back on. No, it doesn't like it. Just get this. Go away. Don't know what I'm trying to do. Wait, this needs to go back anyway. Oh, my wires have such huge keep outs. Okay, that's kind of the best I can do currently. Something like that. Oops. Right. Now, one last task I'm going to do for now is try and sort out this power supply, because I've had to shove it to one side. Annoying, because I had it pretty sorted. So I've got this inductor, have this switching supply, that's some capacitors, oops, don't think, oh yeah, that's the feedback resistors. Now power comes in here, and I've got this big bulk cap here, put it like that, and try and move this back. Yeah. We've got this capacitor, just stick it like there. It's sort of supposed to be as close as possible to the regulator. I might just move the inductor out of the way. Where's our feedback? Pin 4. So I want our feedback resistors. be nice and close to pin 4 like that. I'll probably have a double look at the data sheet again. See its layout advice. What's this? It's on the input. Where's the input? Input is pin 3, so it can just go like that. This was I made a 12-volt ground pour. The output comes past the inductor. Inductor is near pin 2. Oh yeah, I had it the other way round. This time it seems to lend itself better to be like wait, what's this? Oh, that's our boost capacitor that goes between 6 and 2. To be honest with you, I don't know what the boost capacitor does. You can sort of go here, I feel. It's the ground pour. It goes VN as pin 3. Pin 5 is just an enable pin. The ground can just go straight into the ground plane. We've got this weird thing where we have to route. Let's make the trace is quite thick. I'll probably just do it with a via. Oh, pin 2 is the switch. So pin 2 really needs pin 2 needs a really solid connection to here. They put the inductor to the left. I think it makes sense that the inductor goes here anyway. Right over my SD card signal, is it? Might move it down like that. And then we've got this funny thing where the boost they want a really nice solid connection from the switch. Wait a minute. U12 switch, and we'll put it on the inner layer. Might as well just be like that. So this is the output of the switching transistor. If that's a bit silly. It's got a really nice, giving it a low resistance. Oh, what's this? That doesn't need to go to... Let's just do that. But it's going under the inductor, so I'm not sure if that's great, but... Yeah, it's our voltage reference and it's going under the inductor. Let's not do that. Oops. Let's put it on the... So now it's going like that, and then what's this one? Oh, I'm on that layer. Maybe I'll switch this. Oops. Maybe I'll put it on the bottom. No, I don't want to put it there either. Put it on the green layer. No. I can't do that. So I need to get this 12 volts. Just do it downwards. There you go. Oh, that's minus 12. What am I doing? Who knows? What I need. This signal. Do that, and then this signal. These just need to go upwards. And then this 12 volts. Oh, come on. Connects there. And this is just enable, so it's fine to just connect it like that. That's fire, that's ground. So there we go. And then this capacitor's in. I think I'm about to call it a day now. What's this? Oh yeah, that's the, that actually belongs over here, but it's got the wrong ground on it. It needs to have ground from the jack board. There we go. So it looks like that now. Cool. So one more session tomorrow night. I'm going to do the connector board and work on the panel. It's going to be less boring Ben episode than it has been so far. I need to work on how this ribbon cable connects round into this board, and then how all these connectors fit, basically. I need to lay out these, and I also need to work on an actual main board layout too. Alright. For those of you watching, thanks for watching. Try and catch up with me tomorrow night if you want to watch more. Yeah, great. Hopefully I will be able to get this out, and I've got to change all these jack connectors now because they've made them obsolete, or they've stopped manufacturing them. Anyway, thanks for watching. Bye.